Welcome to 12.7 Solids of Revolution. So basically what this picture is showing us is that we'll have a figure that needs to be rotated around an axis. So if you notice, this is showing the beginning of the rotation of this rectangle around this axis. And when it rotates around, you get a cylinder. So you get these different shapes as you rotate. Now when you're rotating, you get a circle for a base. So the first thing you should do is identify what kind of solid you have. So let's get started. All right, number one, sketch the solid produced by rotating the figure around the given axis. So when we rotate this, it's going to be a cylinder, okay? So we have the height of the cylinder, and then we have the radius, all right? So sketch it, which I just did, and identify and describe the solid. Okay, so this is a cylinder with a radius of 8 and a height of 8. Number 2, as we rotate this around, you get a cone with a radius of 6 and a height of 6. Number 3, so how you would sketch this is on your own paper is you could just draw the height, and then like we always do, we just connect the sides and either a circle, which is what we're going to do here. So this is going to be a cone again. The radius is 11 and the height is 14. This here, we rotate all corners and then we connect the sides. That is going to be a cylinder. So what you're doing is you're drawing ellipses when you do those rotations. So the radius is 4 and the height is 9. Okay, number 5, just because it's on the side doesn't mean anything. So we're going to draw the other side of this, and we notice that's a circle, and if it were rotating, you get a sphere. So how do you draw a sphere? You draw this little ellipse with the radius, around the radius, okay? And then you draw a half circle on the other side. All right, so this is going to be a sphere with a radius of 3. Okay, number 6, again, just flip the picture on the other side and then connect the corners with ellipses, okay? All right, so you have a cylinder. The radius is 2 and the height is 5. Okay, so let's do this one. We're going to draw ourselves, and that's a rectangle. So draw a rectangle on the other side, and then connect the corners with ellipses. And what do we have here? The radius is 5, and the height of it is 12. So what'd they do? They said, oh, and it's a cylinder, so we should probably make sure we name it too. So they said it's a cylinder with a height of 5 and a radius of 6. Okay, so that was switched. They switched the height and the radius. Sketch the solid of revolution, then identify and describe the solid. Okay, so first of all, we have a square. We're going to sketch the solid, and the side length is 4. And we're going to rotate it around one side. So pick a side and then rotate it. So draw it on the other side, and then just draw these ellipses. And describe the solid. So we have a cylinder with a radius of 4 and a height of 4. A rectangle with length 6 and width 3. So we could do something like this where we have 6 and the width is 3. Pick a side and draw it on the other side, okay, and then draw your ellipses. So again, it's a cylinder, and the radius is 3 and the height is 6. Okay. Oh, it says rotate around the shorter side. So we got to actually do it like this. So again, this is 3 and this is 6. We'll rotate it around that. So you just get a fat cylinder.
Good morning, teachers. Just a reminder, we will be in the
Okay, so your radius is 6 and your height is 3. Okay, so now we have a right triangle with legs of length 6 and 9. Rotated around its longer leg. So this is 9 and this is 6, and we got to rotate it around the longer leg. So we draw it on the other side. And then we rotate it, which means you draw these little ellipses. So it's a cone with a radius of 6 and a height of 9. So a semicircle with radius 10. So let's draw a semicircle. Okay. A semicircle with a radius of 10 around its diameter. So what you do is draw the other half circle, and then you draw ellipses around the diameter. Okay, so here's an ellipse around the diameter. So that's really bad drawing, so I apologize for that. So this is a sphere with a radius of 10. Okay, so now we're going backwards and saying, what was the original shape of this before it became a solid? So basically, you look at this and think, okay, if you just cut it in half, that's going to be the shape that you had. So basically half of an ellipse, and if you were to rotate it, you would get the football. Same thing with the peanut here. So we're supposed to draw that. So something like that. And if you rotated it around, you would get a peanut-shaped picture. So that's what you're supposed to do. All right. Okay, same thing here. If we draw an axis here and just draw half of it, so you get this little hour-shaped thing here. What was that shape? Just half of that picture. So it's easy to do this two-dimensionally on a three-dimensional picture. So what would this be if we just draw basically a trapezoid? And that's what you get. Okay, so now what we're going to do is we're going to sketch this. So basically, I'll just continue this, draw my ellipse. So we get a cone, and then it says find the surface area and volume. So surface area of a cone is pi r squared plus pi rl, and the volume we'll do in a second. So pi times the radius 12 squared plus pi times 12, and then we got to get the slant height. So we got to do the Pythagorean theorem. 10 squared plus 12 squared equals the slant squared. So 100 plus 144 is 144, and 244, and the square root of that is 15.62. All right, so that goes right here. So we take that times 12 times pi plus the group of pi times 144, which was what 12 squared was. And we get 1041.27. And this is just square units. Now volume it's a cone, so pi r squared. So it's the area of the base times the height divided by 3. So again, we have pi times 12 squared is 144 times 10, and then you equal that and then divide by 3, and you get 1,507.96, and that would be cubic units. All right, number 18, again, if you just copy the picture on the other side of the axis and then draw ellipses, you get your cylinder. So now we need the surface area of a cylinder. Okay. Surface area of a cylinder. You have two bases, so you have two areas of a circle, the top and the bottom. And then we're going to do the area of the side here. Well, the area of a side, if you cut it in half and lay it flat, you're going to get a long rectangle. Okay, 6.8. And then what do you get for the height here? So this is going to be base times height. Okay, so to get this height, this is actually the circumference of the circle. So circumference is going to be pi times the diameter. And the diameter is 12.2 because your radius is 6.1. So here we have it, 2 times pi. The radius is 6.1. The base is 6.8, and your height is the circumference, pi times your diameter of 12.2. Okay, so now 6.1 squared times pi times 2 of them, and that is 233.797. And then we're going to add that to the group of 6.8 times pi times 12.2. And the total of this is going to be 494.42. All right, number 19. What do we get when we draw it? We get a cylinder again. So remember, surface area of a cylinder is going to, you have two areas of the bases, top and bottom, and then you're going to have to do base times height for this rectangle. So this is 7.4, and the circumference is pi times the diameter of, since the radius is 2.5, your diameter is 5. Okay, so 2 times pi times the radius, 2.5 squared. The base is 7.4, the height is pi times 5. So take your calculator and take 2 times pi times, parentheses, 2.5 squared, and you get 39.269908 plus the group of 7.4 times pi times 5. Close that group, and you equal it, and the total is 155.51 square units. Now volume is going to be the area of the base times the height. Okay, so pi times 2.5 squared times the height of 7.4. Okay, so 2.5 squared, you always do exponents first, times the 7.4 times pi. You do that and you get 145.2986, so 145.30. All right, number 20, draw the half circle on the other side and the ellipse around the radius. So volume of a sphere is 4 times pi times the radius cubed divided by 3. That's the volume of a sphere. So we get let's just do this. 8.2 squared, and that's times pi times 4, and then we divide it by 3. And we get 221.21. That's your volume. Now, surface area of a sphere is 4 pi r squared. So 4 circles. So 4 times pi times the radius of 8.2 squared. So 8.2 squared times pi times 4 gives us 844.96. I see I made a mistake on the volume here. I forgot to cube that. So when I actually cube it, it's 2309.56 for your answer. Okay, so this is how I actually go through doing this. Okay, so here's 21. It's going to be a cone, because we're going to remember, if you draw your ellipses, there's your cone. The radius is 3, so surface area of a cone, you need slant height. So you're going to do the Pythagorean theorem. 2 squared plus 3 squared equals L squared. So 4 plus 9 is 13. And the square root of 13 on your calculator is 3.61. Okay, surface area is 2. Not 2. Pi r squared plus pi r L. So pi times 3 squared plus pi times 3 times L, which is square root of 13. So let's figure out the square root of 13 again. Use that long number on your calculator, times 3 times pi. That gives you the right side. And then we got to add that to the group of 9 times pi. And the total should come out to 62.26 square units. The volume of a cone is pi r squared times the height divided by 3. So pi times 3 squared times the height of 2 divided by 3. So 3 squared is 9, 9 times 2 is 18, so 18 times pi. And then divide by 3. our volume is 18.85. So there's your surface area and your volume. And then on number 22, you're going to have a composite that you're going to have to draw. So you got a cylinder and then you got a cone. So first, there's two problems in one. Let's do the cone. Again, you have the slant height, but you don't have the height. So to get the h, it's 4 squared plus the height squared equals your slant squared. So h squared equals 25 minus 16, or 9. So h is 3. So surface area of a cone is pi r squared, pi times 4 squared, plus pi times 4 times the slant. Okay, so what is that? So 20 times pi. And then we're going to add that to the first group of pi times 16. And we get 318.83. And then we need the surface area of the cylinder. So that's pi r squared. For the base, you have two of them. Except you don't count the top one because it's not really a surface here. It's in this part is inside the solid, so that's not a surface. So we have 1 pi r squared, which is the base. And we're going to add, that reminds me, hold on a second. So that means the surface area is the circle plus the top part. So we don't want the circle base because that's inside, that surface is inside the solid. So that's not a surface. So we can't put that in there. So really that answer is 20 times pi. So that is 62.83. And again, on this side, you do have one surface of a circle, and then you need the rectangle that is made when this is unrolled. So that's 8, and then the base of this is a circumference, pi times the diameter, which is 8. So 8 pi, let's see, 8 times 8 pi, base times height. So now what do we have? Pi times 4 squared plus 64 pi. Let's figure that out. 16 pi plus the group of 64 times pi. So we get a surface area of 251.33. Add that to 62.83, and your total surface area is 314.16. Volume of the cone is pi times the radius squared and times the height of 3 divided by 3 because it's a cone. So 16 times 3 times pi divided by 3. So that volume is 50.27. The volume of the cylinder is pi r squared times the height. So pi times 4 squared times the height of 8. And what is that? So 16 times 8 times pi gives me a volume of 402.12. Add those two together, and you get a volume of 452.39. Good job.